Section 5.5, function operations. We're just going to discuss, performing the four operations: adding, subtracting, multiplying, and dividing on two separate functions, and we're basically going to be combining functions to create a new one. Okay, so I'm going to make a table here. The first column is operation. Second column is going to be definition, and the third column is going to be example. Okay, so operation, definition, and example. The first operation we're going to do is addition, adding two functions together. So the definition of adding two functions together would just be f of x plus g of x, and then the notation for that is going to be f plus g of x. Okay, so I'm running running out of room here, but I'll just kind of use a lot of space here for my columns. Okay, so for adding two functions, f of x plus g of x, how you write it in function notation, f plus g, that is in parentheses, and then an x in parentheses after that. So for example, and for all of these examples, I'm going to go back a step. We're going to say f of x is equal to 5x and g of x is equal to x plus 2. Okay, so those are going to be our two functions that we're going to use for all four of these operations. Okay, so when we're adding two functions together, all we need to do is take, I'm going to do this in a different color just so we can separate it. It's going to be 5x plus x squared. Actually, not x squared. I don't know why I got x squared. X plus 2. Sorry about that. And then this is just basically combining like terms. So we're going to have f plus g of x is equal to, we can combine 5x and x, 6x plus 2. And that's your answer right there for if we wanted to add those two functions together. Okay, let's move on to subtracting. Whoops, I'm going to go back to black here. Subtracting, definition, we're going to have f of x minus g of x. That is equal to, notationally, it's very similar to addition. We're just changing the plus to a minus. Okay, so f of x minus g of x equals f minus g of x. Notationally, that's what we're doing, okay? And in subtraction, order matters, so we're going to make sure we do this right. So we're going to have 5x minus, now g of x is x plus 2, and I'm going to put that in parentheses, and that's important. We're subtracting the whole expression, all of this, x minus, or x plus 2. So you can think about distributing a negative 1 here. So this becomes 5x minus x minus 2. Then you can combine some like terms, so we can say that f minus g of x is equal to, so we got 5x minus x, that's 4x, and then minus 2 on the end. That would be your new function, or your subtracted function at the very end. Okay, let's move on to multiplication. So multiplying, so if we have f of x times g of x, notationally, same thing, fg of x. So let's multiply our two functions. We're going to have 5x times x plus 2. This is going to be just distributive property again. Okay, so it's going to be fg of x is equal to 5x times x is 5x squared, and then 5x times 2 is plus 10x, and that is your final answer when we are multiplying. Just kind of a basic example, but the idea is going to be the same regardless of what each function is. We just multiply what we can. If we have to distribute, we have to distribute. If we have to FOIL, we have to FOIL. Just multiply what you can. Okay, whoops. And then the final operation is division. So if we have f of x divided by g of x, notationally what this looks like is going to be f over g of x. Okay, f over g of x. That means f of x divided by g of x. So f of x was 5x. G of x is x plus 2. I don't really think there's anything there to simplify. If there was, you could go ahead and do that. So let's say, just for example, let's say it was 5x over x. Let's say g of x was just x. Then you can combine that down or simplify that down to just 5. But really, that's not that isn't too complicated of a process. If you can simplify it, do it. But if you can't, don't worry about simplifying it any farther. If you can't, just do as much as you can. Okay, so that's f over g of x. Okay, let's try some I don't want to say more complex example, but let's try another example here. So perform the operation, evaluate the new function at the given value, and state the domain of the new function. So we've got different things to do here. So number one, f of x is equal to 5 square root of x, and g of x is equal to negative 8 square root of x. What we need to find here, what the problem is telling us, we need to find f plus g of x. Okay, let's start there. Okay, so f plus g of x is equal to, well, we're going to take 5 square root of x plus negative 8 square root of x. And if it's plus negative 8, you really could rewrite that as minus 8 square root of x. Either way is fine. And then we can combine these because these are like radicals. 5 plus negative 8 is negative 3 times the square root of x. Okay, so that is the first part. Find f plus g of x. We've done that. The next part here, evaluate when x equals 16. Okay, so we're going to do f plus g of, now we're replacing x with 16. And I'm going to be using this function here. Okay, so it's going to be negative 3 times the square root of 16. Let's see, well, square root of 16 is 4, so we're going to have negative 3 times 4, which is negative 12. Pretty basic example, but kind of how we're doing this. Last thing we need to do, state the domain. Okay, so the domain of our function. We're looking at this one right here. What x values work, because the domain is the x values. Well, if it's under the square root, we can't have negative numbers underneath the square root. We could have 0 and we can have positive. So that means our domain is going to be x is greater than or equal to 0. That is our domain for example number 1. Let's try another one here. F of x is equal to 3x cubed minus 2x squared plus 5. G of x is equal to x cubed minus 3x squared plus 4x minus 2. Our first goal is our first task is to find f minus g of x, evaluate when x equals negative 2, and then state the domain again. Let's start with finding our new function. Okay, so we're going to have f minus g of x is equal to, I'm going to put everything in parentheses here, so 3x cubed minus 2x squared plus 5. And we're going to subtract x cubed minus 3x squared plus 4x minus 2. So this is just combining like terms again. Okay, so we've got 3x cubed minus x cubed is 2x cubed. Let's see, negative 2x squared minus negative 3x squared. Make sure we keep our signs organized. Negative 2 minus negative 3 is actually positive 1x squared, so plus x squared. We don't have an x in our first polynomial, so 0x minus 4x is going to be negative 4x. And then we have 5 minus negative 2, same thing as 5 plus 2, so that is plus 7. There is our function, f minus g of x. Next thing we need to do is to evaluate when x equals negative 2. So we're going to have f minus, whoops, let me rewrite that so it's proper. So it's going to be f minus g of, and our x value is negative 2, equals 2, there's an x, so we're going to make that negative 2 cubed plus negative 2 squared minus 4 times negative 2 plus 7. So we got negative 2 cubed is negative 8 times 2 is negative 16. Okay, negative 2 squared is positive 4. Negative 4 times negative 2 is positive 8, and then plus 7. So negative 16 plus 4 plus 8 plus 7, what that gives us in the end is 3. Okay, so our answer for evaluating is 3. Last thing we need to do is state the domain. Okay, with a polynomial function, you can pick any x and it will work. Okay, there's no restriction here. It's not like we can't take a negative number to a power, because we did that right here. We can take a positive number to a power. Obviously, that's an easy one. And then we could be 0 as well. So the domain here is all real numbers. Okay, if you want to write out all real numbers, that's fine. Just remember this is the shorthand. It's 2 vertical lines with an R on the left one. Or you can make an R and put a vertical line through the middle. Either one. Let's try a third one. F of x equals x cubed. G of x equals the square root of x. What we're going to do first is find fg of x. We're going to be multiplying. Okay, so we're going to have fg of x is equal to, so we're going to take x cubed times the square root of x. Now, what I'm going to do, I'm going to rewrite this square root of x as x to the 1/2 power. Okay, remember square root is the 1/2 power. Now, if you have the same base like I do here, and you're multiplying those bases, you can add the exponents. So 3 plus 1/2, would be 3 1/2, obviously. And if you turn 3 1/2 into a improper fraction, what you get is x to the 7/2 power. That would be your final answer. If you want to think about this, you can turn this into 6 over 2. So you have a common denominator. 6 over 2 is still 3. So we haven't changed the value anywhere. So 6 over 2 plus 1 over 2 gives you 7 over 2. Next part, we need to evaluate when x equals 4. Okay, so we're going to have f g of 4. Okay, so this becomes 4 to the 7/2 power. Okay, so think of it, if we're evaluating with rational exponents, we can think of it as 4 to the 1/2 to the 7th. Remember, the 1/2 power is the same thing as the square root. So the square root of 4 is going to be 2, and then 2 to the 7th power. That's not on the half sheet with the table, but you can use the calculator. That would be 128. Last thing we need to do is find the domain. Okay, so the domain here, we have a square root, or we had a square root in our original setup. Okay, so again, yes, we have x cubed, but because we have this square root, we can't have any negative numbers. Okay, so our domain, x greater than or equal to 0. Let's try one more with division here. So f of x equals 4x, g of x equals x to the 2/3 power. Let's go ahead and find f over g of x. So f over g of x is equal to, so we're going to take f of x, 4x, divided by x to the 2/3 power. Now, you do have like bases here, okay? So this is like x to the 1 over x to the 2/3. If you have the same base and you're dividing, you can subtract your exponents. 1 minus 2/3 is 1/3. Okay, so our answer here is going to be 4x to the 1/3 power. Okay, now evaluate when x equals 27. So f over g of 27, we're going to make this, 4 times, there's x, so 27 to the 1/3 power. We need to do 27 to the 1/3. The 1/3 power is the cube root. Okay, so we're going to have 4 times the cube root of 27. Cube root of 27 is 3. So then 4 times 3 gives us 12 in the final answer. Last thing we need to do is state the domain. State the domain. Now, 4x to the 1/3, we can have any x value there because we can raise any number, or we can take the cube root of any number. But when we look at our original expression, we have an x in the bottom. There's a number here that you cannot divide by. If this bottom number is 0, then it's undefined. It does not work. Okay, so what we can say is our domain here is all real numbers except 0, because the only number that gives you 0, so any number to the 2/3 power is going to be something with the exception of 0. If your x value is 0, this isn't going to work because 0 to the 2/3 power is still 0. Okay, so your domain here is all real numbers except 0, but any other number would be fine. Those are all pretty basic examples of adding, subtracting, multiplying, and dividing functions. What if they were a little more complex, like square root of x and 9 minus, so the square root of 9 minus x squared? Your calculators, your graphing calculators can actually help us do this. And the calculators aren't going to tell us the actual function, but we can evaluate these functions using our calculators. And I'm going to show you how to do that. I'm going to give you list out the steps for you. Okay, so we're going to evaluate these functions when x equals 2 for every one of them. Okay, so our steps. First step, I'm actually going to just write these at the bottom and I'll scroll back up. So step number 1, type your functions. Type your functions in the y equals screen. Okay, so that's the upper left-hand corner. So it'll be like y1 equals, in this case, it's going to be the square root of x. And then y2 equals the square root of 9 minus x squared. Square root of 9 minus x squared. Okay, so type functions in the y equals screen. Step number 2, you're going to hit the vars button. So V-A-R-S. You're going to find it right next to clear. Okay, it's in the 4th row down. It's the first row of 5. It's the same row as the math button. Okay, you're going to hit the vars, and then you're going to arrow over to y vars, and then option number 1. And when you do that, you're going to get a list of y1, y2, y3, y4, all the way down. Okay? We need to choose which functions we're going to be using. We're obviously going to be using functions 1 and 2, y1 and y2. But if you have more than one function, or more than two functions, or if you put them in different spots, you can select them from this screen. Okay, so if we want to use y1 and y2, so let's just say that we're going to do example number 1 up here. So we're going to be adding the two functions, evaluating at the x value of 2. Okay, so number 3, we're going to select y1, and then we're going to use parentheses, and we're going to put the x value of 2. And then you're going to go back and do these steps again. Okay, but in this time we're going to choose y2, and then we're going to put a parenthesis 2, and then we will hit enter, and that will actually evaluate the function for us. So right now, pause the video, type in your two functions, these right here. y1 equals the square root of x, y2 equals the square root of 9 minus x squared. And then when you get those done, restart the video, and we'll actually do our 4 examples. Okay, so let's go back up here. So we're going to do f plus g of 2. So what this is going to be, it's going to be y1 parenthesis 2 plus y2 parenthesis 2. So we're evaluating both functions at 2, and then we're adding them together. And what this is going to give us at the end is going to be 3.65. Now, it might be more than that. There might be more decimals than that. Just round to 2 decimal places. If the directions say round to 3 decimal places or 1 decimal place, just do what the directions tell you. But for now, we're just going to do 2 decimal places. Now, a quick little trick to, instead of having to retype all of it again, with these calculators, if you just hit the up button and highlight your last entry, so arrow up to get this, hit enter again, and then it will actually bring up that same expression, and you can actually edit that. So all you need to do then is arrow over to this plus sign and change it to a minus. So it's actually going to go really fast when you have to do all 4. So we're going to be y1 of 2 minus y2 of 2, and then you hit enter again, and what you get is negative 0.82. Okay, do the same thing with multiplying. Do that one in blue. So we're going to have y1 of 2, and then the times button is like a little star flower thing, and then we're going to have y2 of 2, and that's going to be equal to 3.16. And lastly, when we do dividing, y1 parenthesis 2, the dividing sign is a slash, and then it's going to be y2 of 2. When you do that, you get somewhere in the neighborhood of 0.63. So the calculator is going to be your friend here when you have to evaluate more complex functions like these, something that aren't always going to have nice numbers, especially when we plug in 2, because we don't know what the square root of 2 is. But we can help use the calculator to our advantage and do these things fairly quickly. Let's try one story problem here. From 2000 to 2010, the population in thousands of cities M and N, we don't know what they are, can be modeled by these two functions. M of t equals, you can see it there, and N of t equals, you can see that there as well, where t is the number of years since 2000. Okay, we're going to have 2 tasks here. Number 1, find M minus N of t. So we're going to be subtracting the 2 functions. And really, I'm not going to write out the 2 functions again because I've got them right here. Okay, I'm not going to write them out again. But since I'm subtracting and they're conveniently lined up, all I need to do is subtract down because it's M minus N. Okay, so it's going to be, so we'll have M minus N of t is equal to, so 3.3 minus 2.5, so we're doing 3.3 minus 2.5, that gives me 0.8 t cubed. Okay, then do the t squared. It's 12.1 minus 7.87. Sorry, that's not 7.87. I apologize. That was just 7.7. Let me erase that. 7.8. I don't know why I have 2 decimal places. That's the only one there. Okay, so 12.1 minus 7.8 gives me positive 4.3 t squared. And then we do the t values, negative 0.65 minus 0.4. That's actually 0.41. That was where I screwed up when I made this. So I'm going to erase this and try that again. 0.41 t. Okay, so negative 0.65 minus 0.41 gives me a negative 1.06, and that will be t. And then 15.8 minus 11.9, that is positive 3.9. So there's our function m minus n of t. Now, explain what this function represents. Well, we know that this function represents the population of town M. This function here represents the population of town N. If we're subtracting them, what we're really doing is we're finding how far apart the populations are. So this function represents the difference in population, of the two towns, or the two cities, t years after the year 2000. That's what this tells us. Now, if we want to know the difference after 3 years or after 5 years or after 10 years, we could actually plug in those values in for t. But it's not asking us to do that. It just says find m of n minus n of t and then explain what the function represents. Could we do that? Sure, but since the direction is not telling us, we don't actually have to do that.